Orbitals like 1p, 1d, 1f, 2d, 2f and 3f. These orbitals does not exist. And why? Watch this video to clarify your doubts. Welcome to Dr. Sunil Teja Tutorials. Moeller diagram. This was named after Dr. George Thorold Moeller. Before starting to learn Moeller diagram, you should have an idea of proton, electron, neutron, orbits, orbitals such as s, p, d and f, and quantum numbers such as n, l, m and s. Filling up of electrons into orbitals such as s, p, d and f of different atoms takes place according to one principle, namely half-bow principle, which means building up. Half-bow principle is based on Pauli's exclusion principle, Hooke's rule of maximum multiplicity and relative energies of orbitals. Half-bow rule states that in the ground state of atoms, the orbitals are filled in order of their increasing energies, which means the individual orbits contain individual energies. These energies are calculated based on n plus L value. For example, we will calculate n plus L value for two orbitals, 3s and 3p. 3s, n value is 3, L value is 0. Total n plus L value is 3. 3p orbital, n plus L value, n value is 3, L value is 1. Total n plus value is 4. At the end, the energy of 3s orbital is lesser than the energy of 3p orbital. So, the electron first enters into 3s orbital, then enters into 3p orbital. In general, n value should be always greater than L value. To avoid all these confusions, Dr. Moeller designed Moeller diagram. In this diagram, s, p, d and f orbitals are denoted and lines were drawn with directions to show the electrons entering into the orbitals sequentially. So, the line was drawn first on 1s orbital and then eventually the direction goes to 2s orbital and then the direction goes to 2p, 3s and 3p, 4s and 3d, 4p, 5s and 4d, 5p, 6s and so on. In the atoms, the electron first enter into the orbitals of lower energy and then into the orbitals of higher energy. The doubt is, 1s exists but 1p, 1d and 1f does not exist. Why is it so? The reason is shells. In the first shell, the maximum number of electrons that can be accommodated is only 2 electrons. So, s orbital accommodates 2 electrons, so 1s exists. The second shell accommodates 8 electrons, so s 2 electrons and p 6 electrons. Total 8 electrons exist. So 2s and 2p exists, but 2d and 2f does not exist. The third shell accommodates maximum of 18 electrons. So s orbital, p orbital, d orbital exists, but f does not exist. This is the third shell, so 3s, 3p, 3d exists. The answer is justified. Thank you, students.